Yes, sir.
Yeah. Please keep reading maximum power transfer theorem and note down this statement. I will explain later. All of you write down this statement here. Be ready with the books and calculators. We are going to solve the problems parallelly. All of you note down the statement. In any linear active bilateral network consisting of number of energy sources with their internal resistance is driving an external load. All of you note down this statement, everyone.
Excuse me, sir. Sir,
Yeah, you completed.
sir, do you have notes of the second unit, sir?
So far we are in the first unit only. Today we are going to finish the first unit completely. I have already sent the note material related to first unit. Do you want second unit
Sir.
notes?
Yes, sir.
Yeah, I have that notes also. I will also send the second unit notes also. Okay, na?
Yes, sir.
What do you want first of all? You want first unit notes or second unit notes?
Second unit notes. First unit notes already
Yeah,
completed some of the you're saying, sir. This.
yeah. With this, um, today we are going to finish the first unit. Okay, na? Completed. All of you know that the theorem. Please respond. Yeah. So come to the statement here. In a linear active bilateral network consists of number of energy sources with their internal resistance is driving an external load. Then the maximum power is transferred to the load when the load resistance is equal to the source resistance seen by it, the Thevenin resistance itself. Okay. Now, please respond. Everyone is finished. 108. Srivarsha completed, Amma? Did you make a note of it?
Yes, sir.
Yeah. So let me explain the theorem clearly here. So generally in electrical engineering, there is a some terminology called a source voltage, which is a supply voltage, supply voltage, which is denoted as Vs, source voltage, and there is a resistance for the connecting wires that is known as Rs. So this is come under a source voltage and source resistance, and there are some load resistances. So this is a load resistance RL, and this load resistance is going to be variable. I already said that in Thevenin's theorem, the load resistance is going to be variable from time to time. So this is called a load resistance, and this is called a source resistance. Called a source resistance, and this is a source voltage Vs. Now, whenever we want to design any electrical circuit, you should see that there should be a maximum power passes from source to load, such that we have to design. So if you want to design a particular circuit to flow a maximum power from source to load, we have to get the condition to flow maximum power from source to load, maximum power from source to load. Now, when the maximum power is flowing here, according to the statement in any circuit, whenever this load resistance RL is equal to the source resistance RS, that is the statement here. Okay, let us see. If you take any circuit, according to Thevenin's theorem, suppose if it is even a big circuit, we can convert that big circuit into Thevenin equivalent circuit, which is known as, I'm going to Vs, which is VThevenin, and there is a Rs, which is known as R Thevenin. That means we can convert any circuit into a Thevenin equivalent circuit we know very well across AB terminals. And this is a load resistance RL. This is a load resistance RL. So if it is a circuit, I am going to derive the condition for getting maximum power from source to load. That is the statement of maximum power transfer theorem. So when the maximum power flow from source to load, this is a source voltage, and this is a load. This is a source and this is a load. I'm going to derive the condition for maximum power, and condition for maximum power transfer from source to load. Source to load. So the power, we know the power formula. So we know power equal to multiplication of voltage into current, and we know voltage. We know voltage equal to I into R. So now I am going to replace this voltage by I into R into I. So if you multiply this I and I, you will get I square into R. So this is the another formula for power. Okay, V into I. Another one is I square into R also. And we can also have another formula which is equal to, you can write I equal to what? V by R. V by R, which is equal to V square by R. This is another formula for power. So we have three formulas for power. Three formulas for power. So you can use this formula or V into I. Based on the application, you can use any formula for the given problem. Now I am taking this one. Power transfer from source to load. That means load power equal to I square into Vs equal to V Thevenin, Rs equal to R Thevenin. This is the load. Yeah. Can anybody tell me the current in the circuit? We have a voltage source and two resistances. Then how to write the formula for current here? Please, anybody can tell me in the circuit. Tell me the formula for current. Anyone, please? It is a simple circuit. The current through the load resistance 108 Srivarsha. Prasanna. Please tell me the formula for current in the circuit. I equal to V Thevenin by, both are same. We say Vs equal to V Thevenin. V Thevenin by, these two resistors are connected in series. You can write R Thevenin plus RL. So this is the current. So let us substitute this current in this equation. So which becomes V Thevenin by R Thevenin plus RL whole square into, and as we are calculating the power across this load, this becomes RL only. So which is equal to RL. So this is the power at the load. Power at the load. Now, so all of you remember this formula here. Let us say this is question number 1. PL equal to power output or at the load equal to V Thevenin by R Thevenin plus RL whole square into RL, which is equation 1. Now, to get the maximum power, as this load is variable, and to get the maximum power, we have to differentiate this load power at the load with respect to RL. Then you will get the condition for maximum efficiency. Okay. So all of you note down this first. Later I will explain. First note down the circuit. Note down the circuit first. After writing the statement, note down the circuit first. Sai Kumar, are you noting?
Yes, sir.
Please note down. I will continue the derivation because we are going to derive the condition at which the maximum power transfer from source to load. Once we get the condition, then we'll go for statement and we will solve one problem. Completed, Amma? Sai Kumar, is it finished?
Yes, sir.
Yeah. So let us remember this equation 1. I'm going to open another new slide. So in that, PL, power transfer the load, equal to V Thevenin divided by R Thevenin plus RL whole square into RL. We are going to derive the condition for maximum power transfer theorem. For that, we have to variable value of resistance is the load resistance. So we have to differentiate this power with respect to load resistance RL. Then you should make that is equal to 0, which gives maximum power transfer condition. Maximum power transfer. You have to differentiate this equation with respect to RL. Why you are differentiating with respect to RL means this load resistance is variable from time to time. It is not constant, it is going to be variable. But the source resistance or Thevenin resistance or source voltage or Thevenin voltage are constant. So let me do this here. Differentiation of d by drl, which is V Thevenin by R Thevenin plus RL whole square into RL, which implies equal to 0. Now, so you can take V Thevenin square as a common, V Thevenin square, and d by drl of RL by R Thevenin plus RL whole square, which is equal to 0. So which is V Thevenin square into differentiate here with respect to RL. So how to differentiate here? We have to use UV rule. UV rule means first we have to differentiate this RL with respect to DRL. DRL by DRL becomes 1 into U dash V. What is the V? R Thevenin plus RL whole square minus what? RL into, we have to differentiate with respect to RL. So that becomes 2 into R Thevenin RL into, with respect to RL, if you differentiate, you will get 1 into 1. So divided by this is square, P square, R Thevenin plus RL whole square, which is equal to 0. So all of you note down up to this. All of you note down it. Have completed, Amma? Srivarsha 108.
Yes, sir.
Yeah. Now let me continue this derivation. Once if we get this one, let me do it on the top of this one. So if you write this equation here, we will get P Thevenin square into R Thevenin plus RL whole square. Then it becomes R Thevenin square plus RL square plus 2 into R Thevenin into RL minus, so 2 into R Thevenin into RL, 2 into R Thevenin into RL minus RL into RL minus 2, minus 2 into RL square divided by RL plus R Thevenin whole to the power of 4, which is equal to 0. As it is equal to 0, then this will be become 0 and this will become also 0. So which implies, in this, if you observe carefully, and this is 2 into RL R Thevenin and minus 2 into RL and R Thevenin got cancelled out. And here RL square and here minus 2 RL square. So it becomes R Thevenin square minus RL square, which is equal to 0, which implies RL equal to R Thevenin. This is the condition. Now, if you note down, after this step, write down this one. So this is RL equal to R Thevenin is the condition for, let us say this is equation number 2 and this is equation number 1. So equation 2 is the condition for maximum power transfer from source to load RL equal to R Thevenin. All of you note down it. Now completed. Please respond, everyone. Prasanna?
Yes, sir.
Yeah.
Yes, sir.
Now, once if we get this condition here, let us substitute. So when the load resistance equal to Thevenin resistance or source resistance, then the maximum power can transfer from source to load here. Now, then what will be the maximum power value? To get the maximum power value, you have to substitute in place of RL, you have to substitute R Thevenin here. So let me substitute this condition in the equation number 1. Now let us substitute PL equal to V Thevenin plus R Thevenin. In place of RL, let us substitute R Thevenin whole square. So substitute in place of RL, R Thevenin, because you have derived that condition. So which is equal to R Thevenin plus R Thevenin, which is 2R into Thevenin. So V Thevenin square by 2 into R Thevenin square into R Thevenin. There is a R Thevenin. So if you simplify here, you will get V Thevenin, R Thevenin, and square will get cancelled out. And yeah, this is 2 into R Thevenin. 2 square becomes 4 here. So V Thevenin square by 4 into R Thevenin is the condition. After substituting the condition, you will get the maximum power. This is the maximum power which can flow from. So this is condition. This is condition for maximum power. How much power is flowing from source to load? This equation number 3 can be used to calculate the maximum power. So all of you note down, substitute here. In the substitute RL equal to R Thevenin to get the maximum power. So this is the maximum power value. So all of you note down this equation number 3 also. Let us say this is equation number 3 and this is equation number 2. Now come to the statement, then we can able to understand the statement here. Now see the statement here, maximum power transfer theorem. In any linear active bilateral network consisting of number of energy sources with their internal resistances. What is this internal resistance here? Rs, which is equal to R Thevenin. Resistance is driving an external load. External load will be RL. Driving an external load RL. Then maximum power is transferred to the load when the load resistance RL is equal to the equivalent source resistance seen by it. That means which is equal to a Thevenin resistance itself, R Thevenin. Okay, so that means the maximum power transfer can flow from source to load when the load resistance equal to the Thevenin resistance or source resistance. Just now we have proved. So this is the statement. Okay, suppose in the problem if they want to ask to calculate when the maximum power transfer will flow, then if you are able to calculate R Thevenin resistance, and we can easily know when the maximum power is going to be transfer. And we know that the resistance RL is going to be changed from time to time, you know very well. From time to time the load resistance is going to be changed. Okay, this is about the statement. And here to solve a particular problem related to maximum power transfer theorem, for any problem we have to calculate V Thevenin and R Thevenin, and that circuit should have the equivalent Thevenin equivalent voltage as well as resistance in series with the Thevenin resistance, and the load may be same. Okay, so what we have to remember in this, that first thing is that RL equal to R Thevenin, that is the first condition. Then if you substitute RL equal to R Thevenin, we will get a maximum power. That maximum power is equal to V Thevenin square by 4 into R Thevenin. These two formulas you have to remember to calculate the maximum power and condition for the maximum power. Now let us do a problem on it. So all of you note down this problem. Please everybody note down this problem. If you do this problem, then you will get a clarity on this theorem. Ranjit, note చేసుకుంటున్నావమ్మా?
Yes, sir.
Note down this problem. Once if you solve this problem, you can easily understand what is the theorem statement and all those things. And the procedure is same. We did a problem on Thevenin's theorem. Calculation of E Thevenin is same as Thevenin's theorem, and calculation of R Thevenin is same as Thevenin's theorem. If you have perfect about the Thevenin's theorem, this will be very easy. Find the value of RL here. find the value of RL. This value of RL for maximum power transfer in the circuit. For maximum power transfer in the circuit, and find the maximum power also. Okay. So we have already derived the two condition. One condition is, can anybody tell me when the maximum power transfer is taking place from source to load? Just now we derived. Please, anyone respond? Srivarsha, what is the condition? Sai Kumar, what is the condition, Amma? When will maximum power transfer from source to load? Ranjit, what is the condition? Am I audible first of all?
Yes, sir.
Yeah, what is the condition? Just now we derived, right? RL equal to?
R Thevenin.
Yeah, that's it. RL equal to R Thevenin, we have to calculate. So we have to calculate the RL value. This is unknown value. This is a variable value. That value should be equal to R Thevenin. Once we get the R Thevenin, then we can find the RL value. Okay, that is the first one we have to do. Second one is what? Find the maximum power. Just now we derived. What is the formula for maximum power? Please, anybody can tell me? V Thevenin square by 4 into R Thevenin. So for this given problem, across AB terminal, you have to calculate V Thevenin and R Thevenin. So how to solve this problem here? Before AB terminals, this entire circuit should be replaced with the which one? V Thevenin in series with the R Thevenin. You have to replace that entire circuit AB across AB terminal, and this will be RL. So once if you get the R Thevenin, and if RL equal to R Thevenin, we will get the maximum power. Okay. And if you want to calculate maximum power, you have to use V Thevenin square by 4 into R Thevenin. So if the maximum power transfer theorem is given, first you have to calculate Thevenin equivalent circuit, which is V Thevenin in series with the R Thevenin. Okay. Now let us take this problem and calculate the V Thevenin. What is the procedure to calculate V Thevenin here? You have to remove the load resistance first. Remove the load resistance RL and take this entire circuit and calculate the open circuit voltage across AB terminals. Okay. So let me calculate V Thevenin for the given problem. So this is a voltage source. Let me draw the 12 volts and 6 ohms. This is 12 volts and this is 6 ohm resistor, and there is a 12 ohm resistor is there, and there is a 3 ohm resistor, and there is a current source here. What is the value of current source? 2 amperes. 2 ampere current source, and 2 ohm resistor is there. So these are the terminals A and B. We are going to calculate V Thevenin. What is the V Thevenin in the given circuit? Okay. What is the V Thevenin voltage? This open circuit voltage across AB. So VAB, which is equal to V Thevenin. Okay. Now, as it is having the two sources, current source and voltage sources, and 3 resistance, and we can use the any method to calculate the voltage. The voltage of VAB is same as voltage across this 2 ohm 2 ampere current source. So there is a voltage called voltage V 2 amperes. Voltage across 2 amperes is same as the Thevenin voltage. And to calculate this voltage across this one, we know this voltage in the circuit. For that, we can use a mesh analysis or nodal analysis. Anyone you can use. I will go for the mesh analysis here. Can anybody tell me how many meshes are there in the circuit? How many meshes are there in the circuit? How many meshes are there in the circuit? Ranjit?
Sir,
How many meshes are there in the circuit? Please respond.
I think 6, sir.
6 meshes, not branches. After removing RL, this is the circuit mesh. How many meshes are there in the circuit? Srivarsha?
2, sir.
Yeah, very good. Two meshes. This is one mesh and this is another mesh. So let us say this is I1 current and this is I2 current. Our aim is to calculate voltage across these AB terminals. AB terminals. Okay, na? Now, see, write the mesh equations. Mesh equations in mesh 1. In mesh 1. So in mesh 1, write the mesh equations. That is minus 12 volts plus 6 into I1 plus, as it is a common branch, what is the current which is flowing through this 12 ohm resistor? Should I write I1 minus I2 or I2 minus I1? As you are writing the mesh equation mesh 1, you have to write I1 minus I2 because this current is greater when compared to all the mesh currents which are present in the circuit, which is equal to 0. So if you simplify this one, this is minus 12, this is 6i into 12i, which becomes 18i1 minus 12i2 equal to 0. Let us say this is equation number 1. Now, if you observe the second mesh, we assumed that the current is in clockwise direction and there is a current source is readily available. Current source is readily available means this 2 ampere current, this is 2 ampere current, and this is 2 ampere current. So 2 ampere current is flowing, I2 current is flowing. Now, can you tell me what is the I2 value here in the circuit? As there is a current source, we can take directly this current source as a I2 current, but I2 equal to 2 amperes. I2 equal to 2 amperes. But the thing is that we assumed that the I2 current is in clockwise direction, but how the direction of the 2 ampere current is flowing? Upward or downward? Please respond, Amma. This 2 ampere current is upward or downward? It is upward direction. As it is upward direction, both the currents I1 and I2 is downward, 2 ampere current is upward. So that we have to write minus 2 amperes. So whenever the current source is available in any mesh, that current is the same as the mesh current. No need to calculate again I2 here. No need to calculate I2. That mesh current is the same as the current source value. Okay. I hope you are understanding here. Whenever there is a current source in a mesh, that mesh current is same as the current source value. So I2 equal to minus 2 amperes. Why it is a minus 2 amperes? Because we assumed that current is I2 is in clockwise direction, but this 2 ampere current is in upward direction. Okay. Once if we get I2 value, let us substitute I2 value in this equation 1. So minus 12 plus 18 into I1 minus 12 into I2 value is minus 2, which is equal to 0. So which implies 18I1 minus 12 minus into minus it becomes plus 24. which is equal to 0. From this, tell me I1 value here. So from this equation, 18 I1 equal to minus 12, right? Then I1 equal to minus 12 by 18, which is equal to 2 by 3. So I1 equal to minus 2 by 3 amperes. So these are the mesh currents in the given circuit. Once we get the mesh current, we can easily calculate voltage across VAB terminals. Okay, voltage across VAB terminals. And here we can take any loop in the circuit to calculate the voltage across this VAB. That means, suppose if you take this loop also, if you take this loop also, we can write VAB voltage, and we can also take this mesh also to calculate the voltage across 2 amperes. Once we get the voltage across 2 amperes, that voltage is same as the VThevenin. Now, for I am taking this loop, and I am going to write the KVL in this loop. By KVL, tell me in this loop, tell me minus 12 plus 6 into which current is flowing here? I1. 6 into I1. Next, 3 into which current is flowing through the 3 ohm resistor? I1 current or I2 current? Which current? That 3 ohm resistor is related to this second mesh. Then we have to write plus 3 into I2 plus what is this? What is the current which is flowing through the 2 ohm resistor here? As it is an open circuit, the current is flowing through this 2 ohm resistor I equal to 0. Okay, then you can write 2 into 0 plus this voltage, VThevenin voltage or VAB voltage. So as you are taking a clockwise direction and the current is entering at the positive terminal, we can take plus VAB, which is equal to 0. Now we know I1 current value and I2 current value. Substitute I1 and I2 and tell me the VAB in this equation. So all of you note down this. Yeah, substitute I1 and I2 values and tell me the VAB voltage. what are the values of, what is the value of VAB, Amma? Sai Kumar? What is the value of VAB after substituting I1 and I2 values in that equation? Srivarsha?
21.96.
VAB equal to 21.96 volts, which is equal to VThevenin. Which is equal to VThevenin. Okay. So VThevenin we calculated. Next, RThevenin here. How to calculate RThevenin here? Let us take the same circuit. How to calculate RThevenin? What is the procedure? Can anybody tell me? RThevenin. We have to remove the load resistance RL and the resistance, the sources. To calculate the RThevenin here, you have to first remove this load resistance first, and this voltage source is replaced by which circuit? Open circuit or short circuit? Please respond. Voltage source is replaced by Ranjit.
Short circuit.
Very good. And what about this current source? Current source should be replaced by open circuit, and this is replaced by a short circuit, and to draw the equivalent circuit for RThevenin, finding out the RThevenin. So let me draw the equivalent circuit for RThevenin, and this 12 volt source is short circuited, and this is 6 ohm resistor, and this is 12 ohm resistance, and this is 3 ohm resistance. It is a somewhat complex problem to try to understand, and this is current source is going to be open, and this is 2 ohm resistance. 2 ohm resistance, this is A and this is B, and RL is removed. Now see from this side and calculate RAB value, which is equal to RThevenin. We have removed load resistance, and voltage source is replaced by a short circuit, and current source is replaced by a open circuit. Open circuit means the current will not flow here. Now if you see from this side, and current is not flowing in this, and how this 2 ohm resistance and 3 ohm resistance are connected? These two resistors are connected in series, and this 6 ohm and 12 ohm resistors are connected in parallel. Now, what is the value of this? I think 4 ohm one. Is it? 6 into 12 by 6 plus 12. Okay, which is equal to 4 ohm resistance. This becomes 4 ohm, and what is the equivalent of 2 ohm in series with the 3 ohm? A 5 ohm resistance. So AB. Now, what is the RAB value here? Now tell me how this 5 ohm and 4 ohm are connected. Ranjit, how this 5 ohm and 4 ohm are connected?
Series.
Yeah, very good. Series. So then that becomes 4 plus 5, which is equal to 9 ohm, which is equal to RThevenin. So we have calculated VThevenin as well as RThevenin. Now let me draw an Thevenin equivalent circuit of the given problem. For maximum power theorem, compulsory you should calculate VThevenin and RThevenin. VThevenin and RThevenin. RThevenin equal to 9 ohm. What is the VThevenin value, Amma? 21.96.
96.
96 volts. So this is an equivalent circuit of Thevenin for the given problem across which terminals? A and B terminals. Now, and reconnect this load resistance RL. Now, can you tell me what is the value of RL? What is the value of, at what value of RL you will get the maximum power in the circuit? Please tell me, Amma. We completed the problem, right? Then what is the value of RL? Ranjit. So what is the value of RL? Srivarsha?
9.
Very good. Just now we have discussed RL equal to RThevenin, right? What is the RThevenin we have got? 9 ohm resistor. So that is the first problem we have completed. So whenever this resistance is going to be vary, suppose it is varying from 1 ohm, 2 ohm, 3 ohm, 4 ohm, like that up to 9. So during this period, the power transferred from source to load is very less. Whenever this load resistance becomes 9 ohm, then we will get a maximum power. We have already derived, right? So the answer is for first question is 9 ohm resistance. Now second question, P maximum power equal to, the formula is VThevenin square by 4 into R Thevenin. What is the VThevenin square here? 21.96. 21.96 whole square divided by 4 into R Thevenin is 9. Please tell me the answer for maximum power. Please calculate and tell the answer.
13.39.
13.39.
39.
What are the units for power? Watts. This is the maximum power. This is a solution for the given problem. Okay. So please, all of you note down this.